which is this one here. Can you see it now? Yeah, this is example sheet number 10. So there are 5 questions on this example sheet. Can you try and do question 1, please? Question 1 on example sheet 10. I'll give you a few minutes, and after that I will show you how to do it. Okay. All right, guys. So take your time and see if you can do question 1. Okay, guys. Thank you. Um, You guys okay? You guys done question one, guys? All right, let me show. If you haven't done it, let me show you. Let me show you how to do it. Okay. Um, okay. Oh, give me 1 second. Okay. So this is question one. Oh, what am I using? Question one. Okay. The first part of the question one is as follows. So you are given a confidence interval, which is basically the confidence interval that you're given is from p hat minus z1 minus alpha by 2 times p1 minus p divided by n, which is in the square root, right? This is the lower limit. And the upper limit is p hat plus okay, so this is the upper limit. All right. So part one is asking you about the width. Remember the width of the confidence interval is just the difference between the upper limit and the lower limit. So if you take the difference, the upper limit minus the lower limit, you will get the following, which is 2. So this is my 2. Okay, this is 2 z1 minus alpha by 2 times the square root of, okay. So this is the width, and clearly this is proportional. This is proportional. This is the sign proportional to p times 1 minus p divided by n square root. Okay, so that completes part one. That completes part one of question one. Okay. All right. Part two. Um, Part two is asking you to draw the graph of. Is asking you to graph this function for p lying between 0 and 1. Okay. Now, how do you think the graph? I'm sure you've done in your calculus course in the first semester of calculus. You must have done you must know how to graph functions, right? So to graph a function, you need to basically you need to take a derivative first. All right. So let's take the derivative. So the derivative of this is gonna be 1 minus 2p, which is 0 if p is equal to half. Right. Now the second derivative is minus 2, which is negative. That means That means p equal to half. Because the second derivative is negative, the p equal to half must correspond to maximum. And furthermore, we know that b at 0, if you put p equal to 0 into that equation, you get 0. And if you put v equal to 1, p equal to 1 into the equation, you get 0. So the graph, so basically we have a maximum, a point of maximum at half, and the graph is 0 at 0 and 0 at 1. Okay, so the graph must look like this. I'm not good in drawing, as you know, but let me try my best. So this, suppose this is 0, suppose this is 0, suppose this is 1, and suppose this is p of p, and this is p. So basically the graph is takes the largest value at half. So this is half. So the graph must look something like this. It must look something like this, all right? So it is 0 at 0, 0 at 1, and at half, it takes the largest value, which is, so this point, this guy here is the largest value. So if you put p equal to half into the original function, which is p times 1 minus p, you will get quarter. So this point here, this guy here must be a quarter. Okay, do you follow me or not? Hello guys, if you have any questions, just talk to me or use the chat room. Okay, so that's part 2 and part, so this is, so what we just done is part 3 of question 1. All right, we have graphed the function and determined the value. So what we have proved from the graph is that v of p is less than or equal to a quarter. That's the largest value for all p. All right. Okay. Okay, guys. So now let's go back to the width. Remember, from part 1. In part 1, we showed that the width of the width of the confidence interval is equal to 2 times z1 minus alpha by 2 times p1 minus p, the whole thing in square root, right? Okay, so and because p times 1 minus p has an upper bound of quarter, this must be less than or equal to 2 times okay. Now square root of 4 divided, so that becomes, the square root of 4 cancels with the 2. Okay, so this becomes this. Okay, and if n is 1000, so this is the upper bound. So if n is equal to 1000 and 95%, which means 100 times 1 minus alpha is 95. All right, then excuse me. then the upper bound will be 100 times, alpha is 0.05, so that means 0.975 times 1 divided by the square root of 1000. Okay, so this will be equal to, you can read this from the table, I think it will be 1.96 approximately. The square root of 1000 will be, you can work it out what it is. So if you have a calculator, you can determine the value for, excuse me, you can determine the value for this. Okay guys, any questions? So this is question number 1. Is that clear to all of you, or is it, you have any questions, let me know. Please use the microphone or the chat box. Are you guys okay with this? Hello. Okay, thank you guys. All right, can you do the question number 3, please? So this is question 1 on example sheet 10. Can you do question 3? Now, let me show you where it is. Share screen. Question 3, which is this one. Question 3 is this one, guys. Can you see if you can do it, guys? I'll give you a few minutes and see. So question 3, first you need to show that the two estimators are unbiased, and part 2 is to find an expression for the variance and show what happens when n goes to infinity and m goes to infinity. Hello guys, you okay? By the way, if you haven't done the unit evaluations, could you please do it now? But many people haven't done it. Actually, most people haven't done it. So if you haven't done it, please could you? Please, I would really appreciate if you could do the UQ as soon as possible. All right, guys, let's see. Okay, let's see how we can do question 3, right? So question 3 is about you have two estimators. You have two estimators for mu hat. Let's start with the estimator for sorry, just a minute. So this is question number 3. Okay, let's start with the estimator for mu hat. So mu hat is equal to n times x bar. So x bar is the mean of the x's plus m times the y bar divided by n plus m. And we want to show that this estimator is unbiased. So remember, to show that something is unbiased, you need to find the bias. You need to find the bias of mu hat, okay, which is the expectation of mu hat minus mu, okay? Okay, guys. Now this is gonna be the expectation of mu hat is minus this. Okay. Now, if you take the expectation inside, you get okay. Okay, guys, are you with me? Are you follow? Just let me know if you don't follow anything. Just talk to me. Okay. Now you should take the expectations inside the thing. Then you get what n over n plus m times 1 over n times the sum of the expectation of xi. Okay. Then plus m over n plus m times 1 over m times the sum of expectation of y. Okay, minus mu. Now we are assuming that the expectations are all equal to mu, right? Okay, so excuse me. So that means is n over n plus m times 1 over n times the sum of I from 1 to n of mu, right? Then you have m divided by n plus m times 1 over m times the sum of mu minus mu, right? And clearly what you get is the following. You get a lot of things cancel. You get n mu divided by n plus m, and m mu divided by n plus m, then minus mu. So clearly this is equal to 0. So the conclusion is that mu hat is unbiased for mu. Is that clear, guys? So are you okay with this so far? So what I have shown so far is that I have shown that the estimated mu hat is unbiased for mu, right? Now we need to do the same thing with sigma hat squared. So let's see how we can do this for sigma hat. We are told that the sigma hat squared is n minus 1 times sx squared plus m minus 1 times sy squared divided by n plus m, excuse me, minus 2. All right. Okay, this you can write as follows, because remember sx squared is a sample variance for the x's, and sy squared is a sample variance for the y's. So you can write this as follows. You can write this as 1 over n Okay, you can write this as this plus this. Okay, guys, so this is the estimator for sigma f squared. Now, to show that it is unbiased, we need to show that the bias is equal to 0. All right. So I want to find the bias, which is equal to the expectation of that minus sigma squared. Okay. So this is going to be the expectation of expectation of this minus sigma squared. Okay. Are you with me, guys? Let me know if you have any questions. Please raise your hand or use the chat box. Okay. Now, I'm going to do a trick here. I don't know whether I'm going to do the following trick. So what I'm going to do is I'm going to multiply the outside term by sigma squared, which is the population variance, and divide everything inside by sigma squared. Now you may remember that from a long time ago, when I talked about the chi-square distribution, one of the results I mentioned is that if the data are normally distributed, then each of these guys, this guy here and this guy here, each of them has a chi-square distribution. So this one will have a chi-square distribution with n minus 1 degree of freedom. And this one will have a chi-square distribution with m minus 1 degree of freedom. Do you remember that? It's from, if you look back in the notes on the chi-square distribution, you will see this. Okay. So what you have, is that this is equal to sigma squared plus n plus m minus 2 in brackets the expectation of like this. Okay. Now if you take the expectation inside, guys, the expectation of chi squared n minus 1, I don't know whether you remember, is actually n minus 1. And the expectation of chi squared n minus 1 is also n minus 1. Okay. So we get this to be 0. So, okay. So here, I don't know whether you remember the property that, so what the property I have used is the following, that if you have a chi squared variable with a degree of freedom, this is something I mentioned a long time ago. If you look back in the printed notes or the scan notes, you will see this property I mentioned to you. So this is the result I'm using at this line, on this line here, that the expectation of a chi-squared variable with a degree of freedom is equal to a. All right, so what we have shown so far is that, just to summarize, so we have shown that the sigma hat squared is unbiased for sigma squared. Okay. All right, guys. Any questions on? Any questions on this, guys? So just give me a sec. Okay, guys. Did somebody say somebody has a question? Sorry. Did you? Okay. Okay. All right. What did I do here? Stop share screen. Okay. Okay, guys. So we are done with the first part. The first part of question number 3. The second part. So this is part 1. Part 2. Part 2 of question 3 is to find an expression for the variance. Is to find an expression for the variance of mu hat. Now the variance of mu hat is the variance of nx bar plus my bar divided by n plus m. Okay. So if you take the variance inside, guys, you get n squared. Because remember, when you take the variance inside, you need to. I mean, if you're pulling a constant outside, you need to square it, right? So that's what I'm doing. So it's n squared times divided by n plus m squared times the variance of x bar plus m squared okay. Right, now let's see what happens. N squared divided by n plus m squared. X bar, all of you know, is 1 over n times the sum of xi. Okay, and then you have m squared plus n plus m squared, variance of 1 over m times the sum of the y's. Excuse me. Okay, now you should take the variance inside the sum, you will get the following. You get this plus You get this, okay? Now we know that the variance of the xi is equal to sigma squared, and so is the variance of yi. All right, so what you get is this. Okay, this is what you get, and this will become equal to n sigma squared divided by n plus m squared, then m sigma squared divided by n plus m squared. Okay, and if you simplify this further, you get sigma squared divided by n plus m. All right, so that's the variance of mu hat. Okay, now this clearly approaches 0 as n tends to infinity and m tends to infinity. Okay, so that completes question number 3. Are you okay with this, guys? Anything that is not clear, please let me know. Okay, is that clear, all of you? Okay, thank you. All right, can we take a break now, because it's can we take a 10 minutes break, and after that we will continue with some other question. All right, because it's 5 minutes to 11 now in the UK time. So let's take a break now, and then let's take a 10 minutes break, and then we will continue with more questions. Okay. Okay, guys. Hello guys, you okay? Yeah. All right, guys. Can you do now? Are you guys okay? Can you do question 5, please? No, question 5. So you should go back to the problem sheet. Can you do question 5, please? This one here. Question 5. Hello, guys. We are doing question 5 now. If you're just joining us, we are doing question 5 from example sheet 10. I'll give you a few more minutes and see if you can do it. Try your best to do question 5. Then I'll give you like 4 more minutes, right? Okay, thank you. Right, guys, have you done question 5 yet? If you haven't done it, let me show you how to do it, okay? So this is, okay, here we are. Okay, question number 5. Um, so if you read the question, there are, you have a random sample of 288 voters in California, of which 141 voted for the presidential election. Okay, so you have N1. N1 is equal to 288. Okay, and N2 is equal to 216, right? Now, let PX denote the proportion of voting in proportion voting in the presidential election in California. Okay, so P and let PY denote the same thing for Colorado. Okay, so proportion voting in the presidential election in Colorado. CO, okay, excuse me. COLO Colorado. Okay. So these are the two. So and what we are trying to construct a 95% confidence interval for the difference, right? So the question is, so we want 95% confidence interval for px minus py. Okay. Now, you should look back in the notes. You should look back in my notes, right? Either the printed notes or the handwritten notes. You will see the formula is the following. The formula is the following: is x bar minus y bar plus or minus z 1 minus alpha by 2 in brackets x bar times 1 minus x bar divided by n1 in this case plus y bar times 1 minus y bar divided by n2. Okay, so this is the formula that I gave you in the class, right? So look back either in the printed notes or the scanned notes. You will see this. You should see this formula. Now x bar is the sample proportion for the first sample, which in this case is what? X bar is the sample proportion corresponding to the first population, which is 141 divided by 288. Okay, that's the X bar for this problem question. Y bar is the sample proportion for the second population, which is 125 divided by 216. Okay. Okay, and we want a 90% confidence interval. So 100 times 1 minus alpha is 95. So in other words, alpha is 0.05. Okay, so z 1 minus alpha by 2 is I think it will be 1.96, right, approximately. So hence, are you guys with me or no? So hence the 90% confidence interval, sorry, 95%. The 95% confidence interval will be this. It will be x bar, which is will be this, minus y bar, which is this, right? Plus or minus 1.96, right? Then in a big square root sign, you have 141 divided by 288 minus 141 divided by 288, everything divided by n1, which is n1 is 288, then plus 125 divided by 216, 1 minus 125 divided by 216, and everything divided by 216. All right, so this is the 95% confidence interval for the difference in the proportions for California and Colorado, right? So obviously, if you have a calculator, you should be able to work it out. But I will leave it like this, okay? Is that clear to all of you? Any questions you have? Guys, talk to me, guys. Is that okay? So you should be able to work out this using a calculator or what? Yeah. Okay. Thank you, guys. All right. So that's question number 5. So we have done question 1, question 3, and question 5. So there are two more. There are two more questions that we need to, or we can try to do. So let me go back to the problem sheet, which is, where is it? Is this one? Okay, here we are. So we are done question 5. We are done question 3. We are done question 1. So let's see if we can do. Can you try to do question? Oh, let me see. Okay, can you try to do question 4, please? Question 4. Question 4, please. Can you? I'll give you as much time as you want. Can you try and see if you can do question 4? You guys okay? So in this question, you have two brand A and brand B, and you are given the sample sizes, you are given the sample mean, and you are given the sample standard deviation. The question is to find a 90% or 95% confidence interval. Okay, assuming that the common variance is equal but unknown. So you should look back in the notes I gave you, either the printed notes or the scan notes, either of the two. Okay, you will see the formula to use. Okay, so let me if you haven't done it, let me show you how to do it. Okay, so this is question 4. Excuse me, sorry, question. Okay, guys, so this is question number 4. So the formula to use is the following. Um, uh, if you use, I don't know the notation used in the question, just a minute, please. Okay. All right. So the notation, if you follow the notation, sorry. If you follow the notation I used in the notes, this is the one you need to use. Excuse me. This is the SP. This is the note according to the notation in my notes, or in my printed notes or the scan notes. This is the formula you need to use to find the confidence interval, right? Now, if you go back to the question, let's see what X bar, all the things are. X bar is the sample mean for the first population, which is given to you as, in other words, for brand A. For brand A, the X bar is 21.8. And Y bar is the sample mean for this brand B, which is given to you as 18.9. M is the sample size for brand A, which is given as 12, and N is also 12, okay? And SP, I don't know whether you remember, the formula for SP is the formula for SP is the following. Is I think I gave it to you some time ago. You might have forgotten, but if you did, let me write it down again. The formula for SP is if you look back in my scan notes, you will see this formula. Okay. All right. So this is the formula for SP. Now this can be written using the definition of sample variance. You can write this in this form too. Okay. You can write this as X. Okay. You can write this in this form too. Right. Now this, you know what M is. M is 12. So 12 minus 1 is 11. Times Sx squared is already given in the question. So if you go back to this, you will see it is 8.7 squared. 11 times Sy squared is 7.5 squared. And then M plus N minus 2 is going to be 24. 24 minus 2 is 22. Okay, so this is your SP. Now, if you work this out using, a calculator or something, you will get this to be equal to, correct me if I'm wrong, 65.97. Oh, sorry, the square root of it, right? So that's your SP, right? So the confidence interval. So let me say hence. 95. We are looking for 95%. Yes. Hence, the 95% CI or confidence interval is the following. X bar is, we know, is 21. So I'm just copying the formula from above, which is this formula here. Okay. And so X bar minus Y bar. X bar is gonna be 21.8 minus Y bar is 18.9. Okay. Plus or minus T, the percentile of the T distribution, plus degree of freedom is M plus M minus 2, so it's going to be 22. 1 minus alpha by 2 is going to be 0.975. And then you have SP, which is, SP is the square root of 65.97. And then 1 over m is 12. 1 over n is also 12. So this is the formula for the 95% CI. Now, if you read the table for the T percentile, you will get this to be equal to 21.8 minus 18.9 plus or minus, this will be 2.074. And this will be 1 over 6. Okay. Now, if you have a calculator, you should be able to work the confidence interval out. Okay, so this is question number 5. Is it 4? Yeah, question number 4. Any questions you guys have, please? Is there any doubts you would like to ask me on this? Please talk to me, guys. Are you okay with this or not? Hello, guys. Are you? Okay, thank you guys. So, all right, so that's question 4. So the only question we haven't done in this example sheet is question number 2. So can you try, can you try question 2, please? Question 2 from example sheet 10. That's the only thing I haven't done today. The only question. So let me go back to example sheet. So, okay. So it's this one here. All right, this is example number 2. You guys okay? So you have again two brands, brand A and brand B. So you are given the mean and the standard deviation. So for each of them, so and the question, the first part is to, or we'll do the second part first. The second part is to so oh, just a minute. Right. Okay, let's start with the first part. Okay, let's start with the first part. So the first part is to find a 95% CI, assuming that the population variances are not equal. So you have to basically use the formulas that I have given to you in the notes. So basically, I will, okay, because we are running out of time, I will just only do the first part. So let me show you how to do part one. Okay, so this is question number two. Question two. So you are given that the part one. So the 90. We are looking for the 95%. So the formula is the 95% CI. According to is the following. If you look back in the notes, you will see this x bar minus y bar plus or minus z sigma x squared is the population variance divided by m, and sigma y squared population variance for the second sample divided by n. So this is the formula that you need to use. Now, basically, you need to use all the data that you need is given. X bar is given to be equal to 1386. Y bar is given to be equal to 1218. M is the sample size. For the first one is 150. The second one is 200. And sigma x squared, sigma y squared are the population variances. The first one is 114. Sorry, without the square. So excuse me, without is 114. So okay, and sigma y is so sigma x, sigma y are the population standard deviations are 98. Okay, so this is all given to you. So all you have to do is hence just sub them in. So hence the CI is, or the 95% CI is going to be x bar, which is 1386 minus 1218 plus or minus z alpha by 2 is going to be 0.025, so it's going to be 0.975. In square root, sigma x squared is going to be 114 squared divided by m, which is 150, plus 98 squared divided by n, which is 200. All right, so this is your confidence interval, and if you read this off the table, you will get 1386 minus 1218 plus or minus 1.96, which is the table value from the normal table. Then in square root, sign is the same thing, which is 114 power 2 divided by 150 plus 98 power 2 divided by 200. Okay, so this is the confidence 90 or 95% confidence interval for the first part of question 2. All right, and you obviously, if you have a calculator, you should be able to work it out. Okay, and part 2, you should be able to do part 2, because part 2 is similar to the previous question that I did 1 minute ago. So you should be able to do that by yourself. Okay. Okay, guys. So is there some questions you have now? Do you have any questions right now you'd like to ask about anything? Hi. Are you guys okay with this or no? So please try to do part 2 by yourself. Okay. So let me write it down here. So part 2. Please. Excuse me. Okay. Guys. Okay. So have a good day, and I'll talk to you guys tomorrow. So I would like more of you to come. There are only 4 people here today. So only 4 people today, and so please try to get more people to come to the classes tomorrow. So tomorrow we have classes from 11 to noon, and then we have a 2-hour example class from noon to 1 and 1 to 2. Okay. All right, guys. Have a good day and take care of yourself. Okay. Thank you.